Okay, in this in this video, we're going to look at some harder quadratic patterns. And I'm going to suggest that we look at the pattern where we've got 8, 13, 20, 29, and 40 as our sequence. And I want to know what the 20th term is in this particular sequence. So what we do is we follow what we've done what we've always done with the previous quadratic patterns. I'm going to start off with my X and my Y columns. Now, you'll notice I've tried to give myself a bit more room here because I know that this one's going to take me a little while. So I'll just go across here like that. So we've got our 5 X values, 1, 2, 3, 4, 5, and our Y values are 8, 13, 20, 29, and 40. And our first step is with trying to find any sequence and any rule for any of the sequences is we look at our first difference. Okay, so first difference. Okay, and so what I'm doing here, is I'm looking for the difference between each of these numbers. And you'll notice that's plus 5, and then it goes plus 7, plus 9, and plus 11. Now, they're not all the same, so we know that that means we don't have a linear pattern, and so we've got to do another second difference, don't we? So we go second, and we put our line down. And here we note that the difference between each of these is plus 2, isn't it? Now, we know that if that second difference is all the same value, that we will divide that 2 by 2 because we know that it's a quadratic pattern. We just need to find what the value is in front of the x term. And so we go to divided by 2, which is equal to 1, of course. So we know starts off y equals x squared, because the second one here, the second difference, is it's all because we had to do a second difference, it becomes x squared. So now what we do is we substitute values of x into y equals x squared. We take our values of x and substitute them into this. So 1 squared is 1, 2 squared, so I'll just go with yellow, 2 squared 4, 3 squared is 9, and so on, 65. And then we have another difference, my difference 3. And the reason why we're doing this one here is to see what is the difference between our values here and the y equals x squared and our original y values. And we'll notice that the difference between 1 and 8 is, of course, is 7. Been in there, plus 7, we have to remember that. 4 and 13 is this time plus 9. 20 is plus 11. 16 and 29 is plus 13. And 25 and 14 is plus 15. So these aren't all the same. So what that tells us is that we've got another x term. If these numbers, this third difference had been all the same, we would have all that number to this x squared. But it's not. These are all different again. So we know we've got, and we know that because this is all positive, we've got ourselves a plus, and there's a sign here. Remembering that your general quadratic takes the form of x squared plus something x plus or minus a number sort of thing. So we need to do a fourth difference. Okay. Rightio, there we go. We come down here. Whoops. And so if we look at our fourth differences here, the difference between 7 and 9 is plus 2. Okay. 9 and 11 is plus 2. And these are all the same, you'll notice, plus 2. So we take this plus 2 because we expect it's not the same by this fourth difference field. We've made a mistake. So we're going to take that plus 2 and we're going to put it in front of the x. Then we have to do yet another subfield. So sub values of x into y equals x squared plus 2x. Let's put this down. I'll go into green pen this time. So if we 1 into this. So y is equal to plus 2, okay? And we know that that equals 1 squared is 1, 2 times 1 is that, so that equals 3, okay? And I'll just do the rest without showing all the working. But 2 squared is 4, plus 2 times 2 is 4, so that's 8. The second one is 8. 3 squared is 9, plus 2 times 3 is 6, so that's 15. 4 squared is 16, plus 2 times 4 is 8, so 16 plus 8 is 24. And 25, which is 5 squared, plus 10, that's 35. And this is where we come up to another difference.